Hello, friends, and welcome to the Nature Wanderer podcast. This is where we explore nature right in your own backyard or other places that we tend to wander. My name's Paul, and I'm your host, and today I'd like to talk a little bit about the weather. We're close to the end of winter. We're getting there, I know. If you live in the Northeast like I do, or anywhere in the North, it's cold. But it's been kind of a weird winter this year. It's been going up and down, up and down. It's negative wind chill factors last week, and then this week they're calling for 40s. It's just a weird winter. It's been going all over the place with the temperatures. Every time it gets a little bit warm, I head outside. I want to do some exploring, some adventures. In the cold, I sometimes go outside, but I'd rather be inside where it's nice and warm. It just as most of you probably are the same. But this up and down weather has brought some pretty interesting scenes, some beauty in nature, things that we don't get to see all the time, like ice crystals. I was actually out the one day when it was getting cold. I'm talking really cold. It was getting really cold out there, and I noticed that there was a fog. We had a fog in the evening, and then in the morning, after it started to warm up, we got this fog again. And that fog brought in a moisture. The moisture stuck to the plants and froze, creating these ice crystals, absolutely beautiful ice crystals. And the other interesting thing was we had a little bit of a wind, and that wind pushed the ice crystals off of the side of the plants, the side of my bird feeders, the side of some of the dead plants in the gardens. And that's when I realized it's like, wow, nature is so beautiful. And then the sun came out and just doubled that beauty. It made all the ice crystals sparkle. So I was just so amazed. But we get that quite often where I live. When the weather is just right, you have to have the right humidity, right temperatures, you get these ice crystals. But what are ice crystals? Ice crystals are basically ice. So you have water. H2O, water, 2 parts hydrogen, 1 part oxygen, and that water freezes, creating ice. Now, we think of ice like ice cubes. Ice is what forms on the top of a pond. That terrible black ice that we don't see while we're driving down the road and we almost wipe out on it. All of these things are ice. Okay, so how is this formed? Well, water is a liquid made up of 2 parts hydrogen, 1 part oxygen, just like I said, H2O. We learned that at a young age. But what a lot of people don't realize is it takes more than one molecule of H2O, one water molecule to form water, if you understand what I mean. I mean, molecules are pretty small. You've got 2 hydrogen atoms, 1 oxygen atom. They connect together, forming a water molecule. Now, lots of these oxygen and hydrogen atoms are dancing around each other. They're disconnecting, pulling apart, and then they get attracted to another atom. So they're constantly breaking apart and reforming into water molecules. That's what makes water a liquid. Think of it as these atoms, these molecules dancing around constantly, breaking apart, finding new partners, and constantly moving. So you have this liquid water. Now, as it gets cold, the temperature drops, these bonds are not breaking apart as easily. They're like, oh, wait a minute, I need to hold together. It's getting way too cold for me. I know enough of this dancing. I need to chill out. The cold is making them retain the bonds a little bit longer. And therefore, they're still there dancing, looking for new bonds, and they start clinging together. And when they start clinging together more, so now you don't just have the atoms clinging together, you have the molecules starting to cling together more. They start to form a solid, ice. It's as simple as that. Okay, I say simple. It's actually kind of an interesting thing. To nature, it's simple, but in the mind, that seems like a lot going on there. Now, when these molecules grab onto each other, what they do is the two hydrogen atoms form an angle of 104 degrees. 104.5 if you want to really be accurate. 104.5 degrees from their atomic nucleus. So they start grabbing on at this angle, forming all these molecules getting together. They're forming a hexagonal shape. So ice is grabbing together, forming this shape. Now, the crystals are made when all of these molecules start attaching to each other and they start forming these beautiful formations. That's how we get ice crystals. But an ice crystal can't just start from nothing. It needs something to grab onto. That first molecule has to grab onto some dust or some pollen or dirt, whatever. It needs to grab onto something in order to actually form into a crystal. And then the other crystals or molecules start grabbing on to that first molecule, and they keep expanding and expanding. So they need a base. It would be like trying to set something. What's a good example? I don't know. Let's say we have a book. We're reading our field guide, and we decide to set it down on nothing. What's going to happen? It's just going to fall. It's going to disappear into nothing. But if you have a desk to put it on, it has some way of stopping it from going into nothing. That book will sit on the desk. You can take another book, set it on top, another book, set it on top. So you can actually make a pile of books. But if you didn't have that desk, what's going to happen? It's all going to fall to the floor. And if there isn't a floor there, it's going to just keep going. So you need something to start that first molecule, and then the rest can add on to there, forming our ice crystals. So that's how an ice crystal is made. Now, I've been asked before, it's like, well, how do you make a snowflake? Same thing. A snowflake is just basically a big ice crystal. As the snowflake is falling through the air, it's cooling, it's warming, it's cooling, and the moisture in it is grabbing onto, I should say, the molecules in the moisture. They're grabbing onto maybe a dust particle that's floating in the air, maybe some pollen that's floating in the air. It grabs onto something, and then it starts to freeze as it's coming through the air, and it forms ice, that crystal. And then more molecules, more moisture molecules start adding on to that, and it starts growing into this, once again, hexagonal shape. Have you ever heard there's no two snowflakes alike? Now, there was a scientist many years ago who was taking pictures of snowflakes under a microscope, and she did find two that she said are exactly the same. It was disproven because it looked the same. I shouldn't say it was disproven. She was right. They did look the same, but they weren't. The build up of them under the microscope showed that there were some differences in how they were connected, the parts of it. We're talking microscopic, molecular structure of this molecule, the snowflake, made them different. But they're usually not even detectable. When you see two snowflakes under a microscope, and do a Google search, you'll find pictures of snowflakes all over the internet. These snowflakes, they're all different. Some of them are really different. They don't even look like They're snowflakes sometimes. You'll get some that are your typical snowflake, like the ones we used to cut out of paper. Remember that when we were in elementary school and we used to fold paper in half, and you would fold it in half again, and keep folding it until you suddenly realized, I can't fold it anymore, it's too small. And that's when, but you would take that paper and you start cutting corners off, cutting little grooves in it, cutting triangles into it. And when you unfolded it, you had the snowflake with all these arms coming off of it, all these beautiful shapes. But it was always symmetrical. You always had the same design going all the way around. Yet you get these snowflakes that actually don't have the arms. They almost looks like just a hexagon, a sign. It's flat and it doesn't have any points to it. That's because when the snowflake is coming down, it's getting different moisture. Sometimes it goes through a dry spot. It goes through a moist spot. And it keeps changing temperature too. So it'll start freezing, then it melts. Then it freezes again, then it melts. So as it's going through all these changes through the atmosphere, it's changing its shape. The molecules are having trouble hanging on, or sometimes they hang on longer and they just keep changing. That's why we get different shape snowflakes as they come down. So it's just amazing how that works. I mean, there's billions and billions of snowflakes out there, yet no two are the same. I don't know. Maybe there are some that are the same, but we just haven't found them. So they do look much different. And by the way, if you want to see some pictures of ice crystals, I also have a video too. You can find them on my Instagram page, the Nature Wanderer _ in between each word, or you can go to my Facebook page, the Nature Wanderer. You can also find them on the Patreon. If you're a patron, you can have access to an ice crystal video that I took, and it shows you one of the experiments I'm going to talk about at the end of this podcast. But anyhow, when these snowflakes come down, they could be all different. Now remember, they do need a starting point. Usually it's dust or air pollen. Temperatures and vapors change the formation process, as I said, but they do need something to stick to actually make these particles. So all these beautiful ice crystal formations that I'm seeing in my yard, what happened was there was some moisture from that fog. Or maybe it was a warmer day, everything got wet from the rain, and then all of a sudden, it started to freeze. The moisture grabbed onto a plant, maybe one of these winter weeds, as I call them. I always hate using the word weed, but it would grab onto one of these plants, that moisture would freeze, and the molecules would start to bind together. Now, as the molecules bind together, they form this crystal. More molecules will attach to that. More water molecules attached to that, and they just keep attaching, and it just keeps growing. So that's what was forming all these beautiful formations out in my field. So why, if water is clear, why isn't ice and crystals clear? Why isn't snow clear? Why is it white? It all depends on how the crystals are formed. So when the ice is freezing, when these water molecules are freezing to make ice, what happens is they're forming these hexagons. As they're forming together, I mean, the hexagons are making it so that there's air in between the molecules, making them so that it's lighter weight. That's why snow, for instance, is lighter weight than water. Ice is the same, lighter weight than water, because they are freezing with these little spaces in between. Now, if you freeze it differently, if you freeze it very fast, very rapidly, the crystals, the molecules, are very small and numerous, so they bind together quite closely. And because of that, and remember, they have debris in them. That's what started them. You have a lot of debris, which makes it cloudy. That's why ice looks cloudy. Now, black ice on the road, when you see it, that is clearer ice because it freezes slower. So there is more transparency in it. So when ice freezes slowly, what happens is it's not as condensed. The molecules are bigger. The ice crystals are bigger. They don't form as close together, and therefore there's fewer impurities in it. That way it makes it clearer. On the road, when it freezes clear, you can see the black pavement from underneath. So you can't see it. You think it's just the road until you catch a glimmer of light on it or you go sliding across it. There's actually a video that I found on YouTube. If you do a search on YouTube for Lake in Slovakian Mountains Clear Ice, you're going to watch this video of these two guys. They were up in the Slovakian mountains and they found it in the wintertime frozen over. As this guy is taking a video of his friend who's walking about halfway out on this frozen lake, which is, from what I understand, pretty deep. I wouldn't be doing it, but this guy was walking out into the middle of the lake. You can see the ice. You can see the reflection off it. But then he pans down to his own feet, and it looks like he's walking on rocks, but it's not. It's actually very crystal clear ice. The rocks are about a foot underneath him. So it's amazing how clear this ice is. But apparently it's protected enough from the wind that the ice froze very still and it froze very slowly. The water was pure enough where it didn't cloud over. So that's why you can get clear ice, but you need the right conditions. And have you ever noticed when you drop some ice, you get it out of the freezer, maybe it drops on the floor, and you go to pick it up? Sometimes it sticks to your fingers, other times it doesn't. The reason for that, let's go back to how crystals, ice are formed. They need moisture. They need to cling. They need to build off of itself. Your fingers are wet. Okay, maybe you think they're dry. You dried them off on a towel, and then you picked up the ice, yet it still sticks to them. Okay, maybe there's sweat on your fingers. Maybe there's some sort of moisture on your fingers that you don't know. It doesn't take a lot. You pick up that ice cube, and the molecules, the crystals from that ice cube are trying to grow onto the moisture on your fingers, making it stick to your fingers. It won't last long. Once your body heat warms it up, melts that ice, it's going to fall right off your fingers. So don't worry about it. Don't panic. It reminds me of a story. Many years ago when I was younger and my son was younger and I was in charge of a Cub Scout den, one of our parents from one of the kids in the den, she worked at the local fast food store. I won't mention any names, but she offered to bring the kids in on a field trip to this fast food store and see the behind the scenes, see how their burgers are made and their French fries. And so we went to the store. I took her up on it. We went to her fast food restaurant and we did it behind the scenes, and she was showing us the freezer, and one of the other parents asked her some question which distracted her. And of course, boys will be boys. Next thing we know, we look over and here's one of the boys with his tongue stuck to the side of the freezer. The moisture from his tongue actually started to cling because the crystals were coming off of the freezer side onto his tongue. Now, unfortunately, he would have been stuck there for a while if we hadn't gotten some warm water and poured it over his tongue. Oh boy, kids. Those were the fun days. But that's why your tongue will stick to metal when it's frozen. I'm sure you hear it all the time about how someone's tongue stuck to a flagpole. That's why it happens. This is why crystals are formed. This is what it's all about. So let's do a few experiments here. I want you to see for yourself how ice crystals are formed. And these are really fun and easy to do. Now, you will need for this first one, you bottle of water. I recommend getting Fiji water. It doesn't have to be Fiji, but I found that Fiji water seems to be the most pure of most bottled waters. And actually, I'm going to recommend getting 2 bottles of Fiji water. Get 2 bottles of Fiji water, put them in your freezer. Undisturbed, make sure it's in an area where you can get it easily without disturbing it as well. Put it in the freezer for about 2 hours, 15 minutes. You let it sit in there, undisturbed. Now go into the freezer after 2.5 hours, 2 hours, 15 minutes. Go in there and gently remove it. Set it on the counter. You're going to notice something very interesting. It's not frozen. It's still in its liquid form. The reason is, even though it got down below the freezing temperature, the ice temperature, it didn't have anything to grab onto to start forming the ice crystals. So it was still liquid. All those molecules are still floating around in there, waiting to find something to grab onto. Now take your bottle, still in the liquid form, and there's a couple of ways you can do this. You can either slam it onto the counter, or you can just hit it on the side really hard. I like just taking it and just slamming it on the counter. Once you slam it on the counter, you have created bubbles in there. Those bubbles gave the ice, the molecules, a place to grab. So it's going to start grabbing onto these bubbles, and you'll watch as it slowly forms crystals going all the way down. So you have instant ice. So it's a really fun experiment to do. The other one with the other bottle, once again, take that second bottle, and you can do one of 2 things with this. So actually, you could have done 3 bottles. You can take it, once again, very gently. It's still in its liquid form. If it's not in its liquid form, then you disturbed it somehow. Something impure was in the water. Something wasn't right. Try it again. Let it thaw. Put it back in the freezer. Bring it out again after 2 hours, 15 minutes. Should be in its liquid form still. When it's in its liquid form, take it over to the counter gently. Place it on the counter. Take the lid off gently. Take a small piece of ice and drop it in. When you drop it in, you're going to see all these crystals forming off of that little piece of ice you dropped in. A lot of times the little piece of ice will either drop to the bottom or it goes over to the side of the bottle and it'll cling to the side of the bottle. So it's really neat to watch these ice crystals form. Now the third thing you can do is you can take one of those frozen water bottles that you just pulled gently out of the freezer, still in its liquid form, gently take the lid off and pour it over some ice cubes. What you're going to have is you're going to have crystals forming up in a tower off of the ice cube. So pour it slowly. Don't just pour the whole thing on. Pour it slowly over the ice, and you're going to see these small little towers of ice crystals forming over the top. Now, another experiment you can try. You need some cold temperatures for this. If it gets down into the single digits, most sources will say it has to be minus 30, but I've done it in single digits. I'm not going to wait for it to get to be minus 30 because it doesn't get that cold where I live. But if you can get single digit temperatures really, really cold, take a pot, fill it with water, put it on your stove and boil it. After it's boiling, go outside and throw that boiling water into the air. Now be very, very careful. I don't want you burning yourself as you're throwing it. So keep it away from you, but throw it in the air. And what's going to happen is you're going to get a cloud of ice crystals. It's amazing how this works. When you throw it up in the air, what's happening is the water reaches 32 degrees. When it reaches 32 degrees, it can exist as a liquid, a gas, and a solid, all at the same time. Boiling water causes the molecules to move further apart, making it into a gaseous state. That's where we get steam coming out of the water. So we boiled it to get it to that gaseous state. Now, introducing it to the freezing air causes that vapor to condense into droplets, which freeze instantly. And you have a cloud of frozen water. So this is a lot of fun to do. But once again, please be extra careful with that boiling water. Don't throw it right at yourself, just in case it's not cold enough. But throw it up in the air away from you, and you're going to see this big cloud of snow. And basically, it's crystals. You've made ice crystals instantly out of water. Those are the experiments that you can try to actually see how ice crystals form. It's a lot of fun to do. Now that you've learned all about ice crystals, how they're formed, and hopefully you're planning on doing some of the experiments so you can actually see how they're forming, how they actually create more ice crystals, I hope I've excited you enough to get outside and look for ice crystals. The next time you have the proper conditions, maybe you have a foggy day and it's really cold. That's when I usually get the best ice crystals on my property. Or maybe just the weather conditions are right. Don't stay inside. Get outside and whoa. Sorry, I just got distracted. I'm sitting here recording this at my window, watching the bird feeders outside, and a Cooper's hawk just landed. I was wondering why all the birds disappeared. Now I know why. Cooper's hawk just landed on the tree that I have my bird feeders hanging from. And he's just looking around, seeing if he can find one. Cooper's hawks eat other birds. They're a bird-eating bird. They're in the accipiter hawk family. So it's just, sorry, I got distracted. Back to ice crystals. He flew off. Anyhow, I hope I got you excited. Get outdoors, explore the nature around you. Take a look at the ice crystals. Put on a jacket, get warm while you're out there. But don't be afraid of getting outside in the wintertime. There's so much beauty out there. Well, it looks like we're out of time. I've run out of things to tell you about ice crystals. I hope you enjoyed wandering through nature with me. Don't forget, invite your other nature-loving friends to join us. If you haven't already, hit the subscribe button. Take a minute to rate and review the podcast. If you have any nature questions at all or ideas for future episodes, please feel free to drop me a DM on my Instagram page. The Instagram page is at The Nature Wanderer with underscores in between each word. Or you can go to my website at naturewanderer.org. You can also support the podcast by joining my Patreon, which will also give you extras, including videos, education classes. I just put a new education class on last week. Pictures, and much more. Show your support of the podcast and your love of nature by supporting a Nature Wanderer t-shirt, water bottle, backpack, puzzle, or more, which can be purchased at my store, which is linked in the show notes or from my website. Have a great week and keep exploring the nature around you.